Good afternoon. My name is Piotr Verko, and I am the lead software developer of the CloudStrain initiative. Also, I am the team leader of CloudStrain team, and it consists of several young, ambitious software developers regarding testing, backend, API, and front-end development. Yeah. Basically, what I want to tell you about is a short version of the current state of CloudStrain implementation on the front end, and yeah, some additional information regarding the survey and set of questions, and yeah, some mm, kind request for you and for your feedback. So let's jump to the CloudStrain landing page. Currently, only the reinforced concrete and post-tension members cross-section computation module is implemented on the front end. Yeah, this is a quite limited offer, but I think this is nice proof of concept that the concept that the team can work and implement decently high level engineering solution into the browser. So let's start with the single reinforced rectangular section bending capacity tool. Yeah, so basically this tool offers bending resistance computation basing on the cross sections geometrical parameters and material data, and of course the number of rebars that we are planning to use. And the number of and the value of the reinforcement diameter. In the future, we will be trying to further develop this tool in order not to only use the number of rebars, but also an arbitrary total area of main reinforcement and its center of gravity. So basically any type of reinforcement can be used in this cross section. Yeah, the same story is with the double reinforced cross section, where as the result we getting the bending resistance or the maximum design value of the bending moment, and the relative height of the compression zone, and the height of the compression zone in meters. And this module also is fully parameterized and can be computed in multiple ways. Of course, all those modules have some open source unit testing for you, as I've already mentioned in the survey. Yeah, now a little bit more ambitious modules, which are aiming at the design of reinforcement itself. So we are calling it the reinforcement dimensioning, and we can enter the value of the load of the bending. Let's say it's gonna be 4 meganewtons times the meter, and we can calculate such cross section, and the API will return with the appropriate response regarding the necessary amount of reinforcement. This module and also this T-section reinforced dimensioning module both run in the recursive manner. What it means is when I increase the load, the module will calculate the amount of reinforcement several times in order to get the convergence of the centroid of the reinforcement. So when you assume that all reinforcement will be in the bottom row, and yeah, your result will indicate that's not the case, the whole procedure will invoke itself until a correct solution is found. And of course, those modules are also thoroughly tested and calculated. Okay, so that's those two, and the last but not least is our most advanced tool, which is available on the browser, which is this general module for complex loads. I will show you this in the PowerPoint presentation. Basically, we are aiming at free computations of all types of orthogonal cross sections. But basically, we are aiming in the further future to compute also non-orthogonal cross sections, absolutely free cross sections. But for now, we are introduced box, rectangular, double T and T-shaped cross sections, and we can load this cross section with axial force and bending, and or pure bending. All of those cases will be dealt with no problem in this module, and we can introduce the reinforcement and also post tensioning into the cross section. So press stressing tendons are also available in this module, and as a result, we are getting the total and full feedback about the stress and strain levels of each and every one of the components of the cross sections. So we are getting all of the strains and stresses in rebars, in post-tensioning members, so the pre-stressing tendons, and all of the concrete fibers. So getting back to the CloudStrain website, yeah, we can change, of course, the value of geometrical parameters. I won't change them very much, not to introduce any surprising results. Yeah, I will change the concrete class and the steel class. We can introduce yeah, main reinforcement, but not the pre-stressing reinforcement. So typical reinforcement, let's say we have two rows, 100 rebars and 50 rebars for the first and the second row, and on the opposite side, so the upper side, let's say we have 20 millimeters as diameter, and also two rows, 100 in the top row and 30 in the bottom. Yeah, and now we are introducing the load that will be dealt with by the cross section. So let's load this like this, and let's introduce some major compression to the cross section. And now the CloudStrain module asks us whether the press stressing tendons are present in the cross section. Yeah, and I will check it yes, and I will introduce two rows of the press stressing. So let's put the second row in the upper slab. As you can see, currently this is still module under development, so those PT tendons are not put it in the webs. So basically treat this whole module as still alpha testing stage. And now we can define what is the pre-stressing level of the tendons. So what is the axial force from the tendons in regard to the strength of the pre-stressing steel. And we also can change those parameters. And the CloudStrain asks us whether the pre-stressing effect is contained in those two values of bending moment and axial false. Usually, when you're calculating, let's say, bridge, the processing effect is already contained, so appropriate correction of the computation will be performed by the CloudStrain computational backend system to provide appropriate results. So now when I click the calculator button, we will be brought to the results page where all results are available for rebars. As you can see, those two bars, this is the upper reinforcement and the bottom reinforcement results were in regard to strain stresses, and the same goes in regard to concrete and tendons. So full information about the all components of the cross section, and if we are getting close to the limit, the CloudStrain app will warn us and tell us in an appropriate warning that the load capacity is exceeded. Yeah, so basically that's the very short version of the current capabilities of CloudStrain. But please keep in mind that this is only the front end visible part that is currently available for you to test for free. We are working very dynamically on very advanced solutions regarding CloudStrain backend, as mentioned in the survey that we are giving you. The main focus is to introduce also full-fledged finite element analysis capabilities in conjunction with current modules of cross-section calculations. But we are also looking in the direction of the building information management coordination and the ability for CloudStrain to store appropriate BIM models in the browser. Also, if you go to the CloudStrain website, you can see in the upper right corner the sign in and login capabilities, which are currently in test version. What the API design allows users to have is to have the history of communication with the API, so the history and data that was calculated by the API for each user and the results of each calculation. And with addition of further capabilities to the CloudStrain app, of course, the database of users will be far more complicated and will give you very nice possibilities, including some detection of your habits and most optimal solutions for you, depending on the data from other users. So basically that's the capabilities that I wanted to show you. What I want to emphasize is that the aim of the survey is not for you to test, of course you can do it, to test the current modules on the CloudStrain frontend. What we would really appreciate is feedback about the problems that you are having with your current software solutions regarding the design of structures that you are dealing with. And secondly, what we would like you to kindly ask you is to provide some feedback about the potential other modules that could be added to the CloudStrain application, so that it could be an attractive alternative to the traditional hardware software. to the traditional software installed on desktop hardware. Of course, we are perfectly aware of our competition. We are perfectly aware that there are several solutions, cloud solutions that work similarly as the CloudStrain, but we also have some innovative ideas that will distinguish us, I think, from the competition. We have young and very ambitious team, and I'm full of hope that this product will be successful. So thank you very much for your attention, and waiting for your feedback. Goodbye.